Hi, so in this video we study NumPy. So what is basically NumPy? It is a Python library that is used for manipulating arrays. Array can also be called a mathematical matrix, and in this video we will learn about 1D matrix, 2D, 3D. We will create 2D and 3D arrays. It can be used for making masked arrays and has vast applications in deep learning. In simple words, it can be used to perform all the different operations on a mathematical matrix array. It can also be used in linear algebra, Fourier transformations, sorting, selecting, and shape manipulation. It has vast applications in deep learning, in neural networks, and how a NumPy array is different from a Python sequence. So basically, we cannot change a NumPy array like we can change a Python sequence. In the list data type, we have the ability to manipulate a list, and the list can get expanded or can get contracted. But if we change an array, it creates a new array. Changing as in a numpy array creates a new array, and all the values in a numpy array must be of the same data type. So uh, how to create a numpy array? Import numpy as np, and to create a numpy array we use the function np.array, and in that function we write 1 2 3, and it creates an array in which if we print, let's store this np.array in a variable called x. uh, if we print x, we will get an array 1 2 3. So there are different types of arrays: 1D array, 2D array, 3D array, and you can create up to 25, 26, any dimension of array you can create. So to create a 1D array, we use np.array, and 1 2 3, this creates a 1D array. And to create a 2D array, we use 1 2, and we use these square brackets to separate both of the values, and we have stored in this 4 5, and it gives us the result of a 2D array. 2D array is also called a matrix, and a 3D array is called a tensor. So to create a 3D matrix, similarly we input the entries like this, and it creates a 3D array. To check the change the data type of an array, we use d type. So the d type of this array, we change the d type to float, and it gave us the answer in decimal values. And similarly we can change the data type to boolean. So the shortcut of boolean is bool, bool, and it gives us the answer in the boolean expression. So it is giving the answer of the array as true, true, and true. So it only considers 0 as a false. And then we have the np.arange function. It is just like the range function in Python, in which we give a range, and it creates an array in that range. And here we have given a range of 1 comma 11. This means that create an array between the from the numbers 1 to 10. So it creates an array from 1 to 10. And if here we have given 2 in the range, it means that make an array between 1 and 11, skipping every one number. Like with a difference of 2 numbers, create an array. So 1 3 5 7 9, every single number is 2 digits ahead of the next number, 2 digits. So similarly, if we enter 3, uh, it will give an array between 1 and 10 with 3 numbers, with a gap of 3 numbers. So then we have our reshape function. Reshape function is basically used to change the shape of an array, and like we can convert the shape of an array of an array that is 2 by 5 to a 5 by 2 array, or 3 by 3 array to a 2 by 3 array to a 3 by 2 array. So in this example, we convert this is an array, this is a 2 by 3 array, and this is a 2 by 3 array, and we are going to uh, convert, let's make it easy. So we are going to convert this 2 by 3 array to a 3 by 2 array. We have to print a. Now let's see. So it has been converted to a, no, it's like column by rows. So sorry, I was considering the matrix as row by column. Is column by rows. So it has been converted into 3 columns and 2 rows, and to convert it into 2 by 3 matrix, like 2 rows and 3 columns, we can simply change these entries, these arguments in the shape function, and now it will show us a 2 by 3 matrix. And then we have np.ones and np.zeros. These functions are used to convert a whole array to ones and zeros respectively, and they are basically used in deep learning, where we have to convert the whole data sets into ones and zeros just in those encoding and decoding processes. So uh, we have this array and we are going to convert into ones. Let's see what. So it has been converted into ones, and if we want to convert this array, this tuple, into zeros, oh sorry, I used, it is showing syntax error, like I forgot the commas and I have to keep those commas. Let's see what is the answer. And so it has converted all the ones into zeros. And np.linspace, what does it do? Linspace is the short form of linear space. What it does is, let's use this function to show its capability. Like np.linspace, we give a range in it from -10 to 10, 10. It means that show us 10 number. This 10 represents that show us 10 numbers. It shows us actually the how much amount of number we want to show, and this is the lower range and this is the higher range. So if we execute this code, I've already executed this code, it shows us 10 numbers between -10 and 10 in a linear fashion. All the numbers are actually equidistant from each other on the number distance scale. So np.identity, the next function, so it is basically used to uh, uh, show up a identity matrix. And what is an identity matrix? In which all of the diagonal entries are unity, and so we give the argument 3 in this function, and it shows us a 3 by 3 identity matrix. And if I give an argument of 2, it gives us a 2 by 2 identity matrix. So there are different array attributes that we can also use. The first one is ndim. Ndim is actually used to check the dimension of an array. What is the dimension of an array? Is an array 2-dimensional or 3-dimensional? So we have created some arrays over here. This is a 2D array, 1D array. A1 is a 1D array, A2 is a 2D array, and A3 is a 3D array. And we check the dimension of A2, and it gives us that, shows us that it's a two-dimensional array. And if we check the dimension of A3, it is going to show us that it is a three-dimensional array. Why is it showing one? Let's find out. So why is it showing us that it is a one-dimensional array? So let's find out. uh, mm, Maybe one bracket is less. No. So we have changed the values of A3, and it is a two-dimensional array. And in the next video I will explain to you guys that why is a two-dimensional array. So let's hop off to the next attribute, that is shape, and it basically tells us the shape of this array, like it's a 2 by 3 array or 3 by 3 array. So A3, if we recall this, it will show us that it is a 4 by 3 matrix. Similarly, the size attribute tells us that how much is the size of an array, how much number of entries in a matrix, like how much the total number of entries are in a matrix. So if we give it A3 by size dot size, what it says is that it has got 12 entries. And similarly, we have another attribute called item size, and what does item size does is that tells us the size of array in our RAM, size of an array, like how much bytes an array occupies in our RAM. So A2 does the item size of A2 is 8 bytes. So similarly, to check the data type, whether an array is an integer or a float or whatever it is, we use the attribute called .dtype. So the next is how can we change a data type in Numpy. For changing a data type, like here we called this attribute to check the data type, and the data type was int 64. So this is a 64-bit integer. To convert this 64-bit integer to a 32-bit integer, we will need to actually call this function called dot as type, a1 dot as type dot, and in the bracket we call this function dot int 32, and it converts integer 64 data type to integer 32 data type. When working with GBs and TBs of data, this is very helpful because it helps us save bigger amounts of memory. So next is the operations that we can do with an array, the number of the operators we can use with an array. So scalar operators, scalar operations are those operations that are used between an array and a number. Like here we multiply the whole a1 array with 2, and it multiplies all the entries in a1 with 2. Similarly, we can add 2 in a1 and it will add 2 to all of the entries. And similarly, we can multiply, we can divide, we can get the remainder, we can get the exponent of we can get the square root, we can get the exponents of a1 by using the SAM functions in operators. So similarly, we can use the relational operators. And what are relational operators? Relational operators are like greater than, less than, is equal to, less than equal to, greater than equal to, and all of these operators are called relational operators. So here we have user logic a1 greater than 5, and it gives us a boolean array of that is like this: all of the values that are lesser than 5, that are greater than 5 are given as true. All the values that are greater than 5 are given as true, and all the values that are lesser than 5 are given as false. Similarly, we have vector operations. Vector operations are the operators when we use operators between two arrays, not like an array and a number. It is used between two arrays, and here you can see like arithmetic vector operations. These are two arrays that I created. But Give one thing in mind, that while using a vector operator, you have to have the same data type of both arrays. Like both arrays have two entries, so the data type of both arrays must be equal. And we are gonna add these to A3 and A4, so it gives us this sum, which is the sum of A3 and A4. Similarly, we can multiply A3 and A4, and it gives us the product of A3 and A4. Similarly, we can divide A3 and A4, we can subtract A3 and A4, we can do all of the operations between A3 and A4. And that was a basic overview of Numpy. It's a vast library, and we will cover other functions, and there are lots of more functions that we can use in NumPy. Like if we so these are all the functions that we can use in NumPy. You can see there are lots of functions, and we will try to cover each and every one of these functions. And let's actually give a recap of what we studied. So we studied how to import NumPy, how to create a simple NumPy, and how to create a NumPy array. Oh, what the hell? I'm sorry. So we created a 1D array, 2D array, and 3D array, and D type we used to check the D type dot a range function. We use the reshape function, dot ones and dot zeros function, linspace, identity, which we got to know how to make an identity matrix. We studied the different array attributes, dimensional, shape, size, item size, t-type, and how can we change the data type from one data type to another, and the array operations like scalar operations, arithmetic, plus, minus, multiply, divide, and vector operations that are between two arrays, plus, minus, multiply, divide, and relational operators. And that's it for this lecture.